Alright everyone, welcome to the first lecture for APC. We're going to cover conversions in this lecture, so let's get it going. First thing we need to do is ask, what is physics? I'll allow Sheldon Cooper to explain. Hope you enjoyed that. We'll be doing lots of that throughout the year. Like Sheldon said, physics is knowledge of the natural world. We're trying to understand how the world works. So first one, to actually not just think about how the world works. The Greeks love to just observe and think about how forces in motion work. But Galileo was the first one to actually put these observations to the test. So he was the first one to do experimentation on the observations that he saw. So drop things off of buildings, Leaning Tower of Pisa, or roll things down ramps, time things, swinging candles in churches, which got him in trouble with the church a lot. Newton came along and used all of Galileo's observations and all his results from his experiments, and there was not enough math at the time to explain his observations. So Newton developed calculus to explain all the observations that he saw. So the language of physics is mathematics. If you don't have math and you're not good at math, well, you better get better at it, because that is how we do physics. The first thing we want to do in math, or the first thing that we're going to cover, is conversions. We're going to do a lot of different units. So the first thing we need to talk about is conversions. In physics, we're going to have lots of measurements like velocities, forces, energies, and all those things can be expressed in three base units: length, time, and mass. The different measurement systems are used all over the world, so it's very important to know how to go from one system to the next. So a length in Europe would be measured in meters or kilometers, while here in America or the States we have feet, inches, miles, all those good English units. Physics uses the SI units, the Système International units, with the base being seconds for time, meter for distance, and kilogram for your mass. So those are the three that we're going to focus on and help you do some conversions. All this chart that I'm showing you right here is just, like it says, a quick Google search. I just said conversion factors, and here's what I got for length, mass, and time. These are just a few. There are multiple conversions for pretty much everything that you are going to use in a course, but the ones I want you to practice for the summer assignment here are length, going from meters to centimeters, or meters to inch, inches to miles, miles to kilometers, or whatever unit I'd ask you to. Mass, we're going to stick with the metric with grams and kilograms. There's a conversion factor from grams or kilograms to pounds, which is what you're used to here in the States. 2.2 pounds for every kilogram is your conversion. It's a very quick one. It's not what the chem people like to use, but you can see the time units down there, seconds to minutes, minutes to hours. I do like the 1 hour is 3,600 seconds. It's a very quick conversion for you. And your year, if you need to go that far into your conversions. And like you can see, we've got many examples of using all these different systems out there in the world, from bridge heights to weight limits to speed limits. And that 200 there, is that miles per hour, kilometers per hour? If you get pulled over, you better be able to defend yourself and know why. So that's what we're going to focus on here, and if you go through the packet and want to check your answers, check the next couple videos on unit conversion answers.